Control schedule is the process of monitoring the status of project activities to update project progress and manage changes to the schedule baseline to ensure timely completion. The control costs process in project management focuses on monitoring project financials to detect and address any variances from the approved budget. Using inputs like the cost baseline, project funding requirements, and work performance data, project managers apply tools such as earned value analysis, forecasting, and variance analysis to evaluate project spending and predict future performance trends. Outputs from controlling costs include updated work performance information, cost forecasts, change requests, and updates to the cost baseline and project documents. This ensures that financial resources are properly managed throughout the project, helping to maintain control over costs and deliver the project within its approved budget. The control schedule process in project management involves monitoring the status of project activities to update project progress and manage changes to the schedule baseline. It uses inputs like the project management plan, project schedule, calendars, and performance data to track how work aligns with the original plan. Tools such as variance analysis, critical path method, and resource optimization help identify schedule deviations and evaluate alternative courses of action. The outputs of this process include updated work performance information, revised schedule forecasts, and necessary change requests. It often results in updates to project management documents such as the schedule baseline, cost baseline, and risk register. Overall, controlling the schedule ensures that the project stays on track, timely addressing any issues that could cause delays or inefficiencies. The control quality process focuses on monitoring and recording project results to assess performance and ensure that project outputs meet the required quality standards. Inputs such as the project management plan, quality metrics, work performance data, and approved change requests are used alongside tools like data gathering, inspections, and statistical sampling to measure quality and identify defects or variances. Outputs include verified deliverables, quality control measurements, work performance information, and change requests, which can lead to adjustments in the project management plan or project documents. By systematically controlling quality, project teams can ensure consistent outcomes, reduce rework, and enhance stakeholder satisfaction. The diagram shows how product vision drives the product roadmap, which in turn informs the release plans. Each release plan outlines a series of iterations where prioritized features are scheduled for development. These features are detailed through user stories, estimated in story points, and broken down into smaller tasks, estimated in hours, to guide the team's work during each iteration. Within an iteration plan, features are selected, decomposed into tasks, and scheduled to ensure progress toward delivering the product. By organizing work in this way, agile teams can manage priorities, track effort, and ensure alignment with the broader vision, resulting in more predictable and focused deliveries across multiple releases. Measuring progress in a traditional project involves continuously monitoring task completion against the schedule baseline, updating the timeline with actual data, and formally managing any changes to the approved plan to ensure the project remains on track. In an agile approach, progress is evaluated by reviewing working deliverables in sprint demos, comparing completed story points to the sprint goal, measuring the team's velocity, and holding retrospectives to adapt processes for future iterations. The two project schedules shown illustrate differences in complexity and task distribution over time. The top schedule 12-15 has fewer modules and a more evenly spaced, sequential task flow, suggesting a simpler project with a steady workload and clear dependencies between phases. In contrast, the bottom schedule 15-18 involves more modules and a denser overlap of activities, indicating a more complex and parallelized project structure. Tasks are more fragmented and concurrent, which could offer faster delivery but also requires tighter coordination and risk management. This diagram illustrates how team-level backlogs integrate into ART, which stands for Agile Release Train. Backlogs and Solution Train backlogs. Each team manages its own backlog of features and stories, aligned with the broader ART objectives. These ARTs then coordinate at an even higher level to align with the solution train vision, ensuring all activities stay synchronized toward delivering large, complex solutions. It highlights the hierarchical yet collaborative nature of backlog management, where alignment across teams and ARTs is crucial, but each group retains enough autonomy to work efficiently. The colorful, interconnected pathways symbolize how multiple efforts converge towards shared goals. Schedule network analysis is a technique used to generate the project schedule by modeling project activities as nodes in a network and analyzing their dependencies and durations. This analysis identifies critical paths, calculates float, and determines the early and late start and finish dates for each activity, ensuring the schedule is both realistic and robust. It is a fundamental process for validating that the project can be completed on time and for identifying where flexibility exists within the timeline. Thank you for your unwavering commitment to excellence and your dedication to mastering the profession. We wish you resounding success on your path to certification.